Hello again, everyone. Welcome back to the working session for this week. John's having a couple technical difficulties regarding his camera, so he is not currently on right now, but he's working through it. In the meantime, I just want to mention that I'm very open to feedback regarding these sessions. So I have tried something a little bit different with the thumbnail of this one. I was trying to think about what information is useful in the thumbnails for these videos, both for people now and for people watching them back later on. And I figured that adding the date in is maybe a good way to timestamp it. But I don't know. If you have any thoughts, literally at all, sorry, John, the stream is going now, so I'm filling in time, I guess. But yeah, so if anyone has any thoughts whatsoever about how I can format these, or what information you would like to see in the titles or the thumbnails, so that I can easily distinguish the working session streams from the other streams, I'm all ears. Yeah, very open to it. But yes, for now, John has resolved his technical difficulties. Great work. So now, I keep forgetting I need to get rid of my camera on this one and put this down here and do that. Cool, so it should be good. I meant to add a little thing to cover over the meeting code, but whatever. That's fine. Cool, so you are live now, John.
All right. Yeah, so I guess you want to go through the model of what we've been working on in the hand and the hand actuator design.
So my main interest at the moment is whether or not you would change anything about your design if you were re-implementing it now. Because I am intending to, as I said in the other stream, I'm intending to pretty much recreate the basic functioning of your design into something that I can just mount on this ring, basically, so that I can very, very quickly and easily just plonk it onto Dogglebot and be off to the races. Yeah. So what works well, what doesn't work well, what would you change? I mean, to be honest, it looks like a lot of it works pretty well. But yeah, general thoughts, I guess. And also if you have any ideas on the belt stiffness that I was talking about.
Yeah, that friction.
Yeah, it's unexpected. Also, you got to get there's a Chrome extension for Onshape called, I think, Onshape Dark Mode or something like that. It's very good. Easily worth the $2 or $3 or whatever it was. I hate white screens.
Well, I have your model in here, but it's not nice to overlay it, because I think that does a lot to do what you were leading into there. Let me try reloading it and see if it'll show. There's a shadow of it there, but
I think I'll try and open the same thing and see if I can get it on my end.
It's almost certainly that we're trying to do this live that it's fighting back. This has been working great.
It just knows, you know?
I can tell. All right, well, maybe dive into the hand, because the integration with the frame platform is kind of one piece of it, but we could talk about how things are working and that first. Hopefully this lets me spin this around. So I guess to back up, this started as kind of a test bed to just try out the motor and that gear ratio reduction and get some basic tuning and that kind of testing going. And that's definitely a goal of the test bed. But this version of the model was kind of a crack at what could go on the hand platform. If it will show, goodness. Right, so I took kind of lessons learned from what we, from building the one the first time and what would tighten it up for integration with the robot. So it has the same tensioner pulley to turn the string around top and bottom.
I actually have a question about that. So I replicated that initially in my belt design, and I had this little element here. Originally, the pulleys were side by side, like your ones are, but I had the problem that I mentioned where they were sized differently in the newer ones. But I quickly realized a problem, which is that with a belt, if I'm trying to tension this using that bolt in the middle there, the belt is directly covering where the bolt is, which I didn't realize until I had it all put together and I went to tension and I'm like, oh shit, there's a belt in the way. Is that just not a
Yeah,
problem because you're using a string? You can just like push the string out of the way?
I tucked the string, off to the side.
Yeah.
And there's a little bit more space on the last one. I think this just barely squeaks through, and I had to tilt the hole just a little bit. But yeah, this ends up being like a jack screw to lift this end up, and then you have the two fasteners on each side to lock it to the rail. So all that works together to hold it. But really, it's the screw that's kind of taking a load and holds it up.
I really like that idea. You only need to move the screw half as much as you're tensioning the two strings, which is so good.
You can get as much stroke as you want out of this, but you really only need enough to take up like a wrap, because then you can go down to the spool and add a wrap, I think is kind of my thinking here. So between this top and bottom, if you had like, I don't know, 5 millimeters probably planned for adjustments, and then if you were that far out, you could go add a wrap to the spool and it would take that back in. It's really good and solid, and it's a nice, like, if we had a way to measure the tension on the line with like a line 3-point bending tester kind of string tensioner, like if we wanted to set the pre-tension accurately, you could just kind of turn this up and then lock it down.
And it's so perfectly centered with the aluminum extrusion. That was another difficulty I had with adapting that tensioner to the linear guide rail, is that if I want to put a bolt straight in the middle, that's exactly where the guide rail is. But with the aluminum extrusion, it's perfect. There's a hole there that's often tapped already. Like it's made for this.
It's what it's for, yeah. They leave it there
clever.
so you can attach to the center of that. So it worked out pretty well. There's the screw that attaches the two together. That's really just to like prevent it from like splaying out under load, but also kind of holds the thing together a little bit during assembly. Let me section through the pulley, show you a little bit. This is like maybe one response to the friction and but also kind of just the design of the way this works. I don't know how you're attaching these. I'm just using a fastener, but what I've got here is a trapped dowel pin. So this gives you a really nice bearing surface onto the plastic in this hole. So it shouldn't like squish in with putting like a thread and shear here, but it's also a really good fit onto the bearings that slides through.
That is a good idea. I've just been using bolts and having like the bearing run on the bolt, which obviously doesn't fit perfectly.
Yeah. So thinking about like tension and creep and all of this, like it may not just be the line stretching, actually creeping. There's a number of things that can appear as like loss of tension, and that's one of them. If the threads kind of start working their way into the plastic, the route gets shorter. So I think this ends up being a pretty good design.
Some of those dowel pins. And that works nicely as well with having that printed as 2 halves. You can just like insert everything and then sandwich it all together.
This kind of started very rough, and there's been some evolution to get it to this. So I think I really like this. It works well with the rail. Yes, the rail's a little heavier than you probably want, but at least for now, and I mean maybe forever, if this ends up being really robust and it doesn't end up being too heavy, it's really nice.
Yeah, so I think you've landed on a pretty good design here. I was thinking of how to like describe this before, and it's like I don't know how long you've been following this project for, but I remember in a video, it would have been over a year ago now easily, I was saying that like when I first came up with the design with like pulling the string and then having the hand move up and down with the springs, and I was saying how the hand is easily the hardest thing that I've like, it's literally my first contact point with Jugglebot, like for actual design stuff, was designing the hand. I'm not going to go into what that design was, but it was pretty bad, and it's definitely been a long process of getting better and better. And honestly, I think that you've landed on pretty close to the asymptote of what this could be. Because this could be so easily mounted on like anything. You could have this on like a Core XY sort of frame. You could mount it on like an actual arm. Just like whack it on there and then good to go. It's pretty good. I'm
Yeah.
a big fan of this design that you've come up with.
Well, thank you. And yeah, I mean, it kind of sit there. I mean, it takes some thought to kind of polish out a lot of these little details, but I think it does a pretty good job to do the things you want to do. A couple of details I'll hit quickly. So these stop blocks have a little notch in here. One of the problems with the 9mm rail is that it wants to fall into this extrusion profile. There's this weird little like step in the top that it will like rock one way or the other into. So like a little bit bigger rail would be better, but we're trying to save weight, and this seems plenty big enough. There's another kind of rail that I had originally, and it sits on there really nice, but this I think is the more common one. Maybe, I'm not sure.
Yep, I just measured the one that I've got, and that gap in like where it starts to taper down on the end is exactly 9mm. So I anticipate having that same problem that you just described. Yeah.
Okay. So what I did, there's enough of the land, just enough that if you keep it centered, you could assemble it, but the block does this. So I've been putting these features that drop into the rail for location to kind of clock things, and then this holds it in the center. So this does a pretty good job of lining up the rail while you then put in the fasteners down the length of the rail.
Have you been putting those in for each bolt the whole way down?
Half of them. I think half of them is probably enough, but
yeah,
I mean,
for now at least.
Yeah, it's stiffness, like you don't necessarily like it feels pretty stiff, but then when you hit it hard, that like you can move this rail surprisingly far, and like for precision applications, it matters a lot more. For this, we have dynamic stuff happening, so if this is bouncing around, then that energy can't be absorbed by the motor as damping. It's like generally what I'm thinking about when I say you kind of want this to be stiff in order to control the ball as you're catching it. So you either need to do it very actively and control the position, or the ball's going to deliver force into the hand, and then you want to suck it up with the motor as kind of a damper. Either way, you don't want this thing. Yeah, like if this is a spring, like any actuated system where you're like trying to control the position on the other end of like a really stretchy like rubber band, like ball screw that's too thin or anything like that, like you end up with this like oscillation, and you can't turn up the bandwidth any further because it's like a spring mass, and you're trying to position the mass, and you move it over here, and it's you just can't move it around fast enough, and it ends up oscillating and can have stability issues. So all of that's not necessarily a big problem, but just the catch and how well that works, I think, is the first one we'll run into, where it really helps to have this fairly stiff connection to the motor, and also just making sure the hand is where we want it to be.
Yep. Is there on the hand as well? Actually, is there a reason why you're keeping it so far out from the rail? I've noticed in all your designs, it's so far out.
It's just a number that
it needs to be.
Maybe just the cone that's open above this is what I'm thinking about, and that's why it's out here. I mean, it hasn't really been an issue. It's not even at the top
right now. Like surely when it's at the very, very top, that cone is huge in the current setup. Or can the hand not move up higher than what it is right now?
So, but no, it can. It goes all the way up to the stop block here, so it uses the full stroke of the rail. What I'm thinking about is like when you're catching, so you're going to catch the ball, kind of come halfway down, and if you're throwing it high, you're going to like wind up, go down to the bottom, and then throw up again.
Yep.
And as you're doing that, you're going to be positioning the platform, and I can foresee like the top of the rail might, like if the next ball's coming in, like the top of the rail, you have to start to worry about intercepting other balls and that
maybe
crashing.
You'd be surprised that there's a good amount of time between one ball leaving and the next ball coming in. Granted, I'm not a 14 ball juggler, so what do I know? But at least for like 3 in one hand, you got a long time
Yeah.
to move.
Yeah. So if the balls you're juggling above, that definitely it's not an issue.
Yeah, for super
But as
low
things are getting
throws.
tighter, you really need to. I don't know. Like if you're catching up at the top, yeah, it's not gonna be an issue. But that's the reason I stuck it out further, and I don't think it. And also just the precision, like as you pull it closer to the rail, it's just like this wall that's kind of in the way. So
Yeah.
it's arbitrary. There's just a variable that you can
Yep.
change to pull this in. So that's easy to be whatever we want it to be.
Mm-hmm.
Another thing I'll highlight is termination of the string, and we can chat about the belt termination here. Let me open this one. So what I did, I think I showed this in Zulip, there's kind of a loop groove that goes through the backside. So the dyneema gets an I splice, so it loops back into itself. This is
Yep. Perfect.
Go ahead. Yeah,
No,
so that's
that
like a
okay.
very, very robust way to terminate the line. It should never slip. And it should be 100% strength of the line. It should break basically above where it loops back into itself at 100% strength of the line. So that's good. And this should not go anywhere. And this is a really strong attachment. So I've had no issues with this. This just kind of pops in here, and then you put the fasteners in, and it's trapped in the rail. So this is working really great. I think this is a good answer. If you were to do a similar thing with the belt, I can foresee like basically printing a linear rack of belt grooves in here. It's backwards if you were to put the teeth in, but I guess the simple example is if you cut the grooves here. I think I've seen like basically you need like a second piece where you have another part that clamps on from the backside here.
I
teeth
think
in it.
I
The
think
bolts
that's the right
through and holds together. So now it's transferred through that back plate and up through the belt, and it should like clamp down and squish the belt a little bit when you clamp that up. You have to play a little bit with how much you're squeezing it, but there should be no lash, and it would be really solid, I think.
Yeah, I think if I took like just the end part of the one that I've come up with and just like cut off the last 3 millimeters had that as a separate piece to then clamp the belt, and then I can bolt this whole thing onto the carriage. Yeah, I think that would work a lot better. I think it's a good idea. Yep.
But on the friction, it's surprising how like having a lot of pulleys and just all the little details add up. So I think there's a little bit of that probably going on. Like make sure you have clearance on the sides of your pulleys, and you want the bearings to be touching at the inner race only. That's maybe one, but in general, like small pulleys and belts are not as efficient. This is similar to chains and gears. Like you lose a lot of efficiency the smaller you go. So it's kind of a trade-off. Like the teeth have to kind of slide as they go in and out of each tooth, and that adds up. So that's all just torque that you have to drive that pulley, and it ends up just being efficiency losses. So I don't know. It might just be a little bit inherent to the belt, and the capstan drive and the string is pretty efficient. And that's, I think, one advantage of the Dyneema is I think it actually helps improve efficiency. It's like pretty slippery smooth over all this stuff.
Yeah, that's a very good point. I've got to get some larger Dyneema so I can start doing that splicing. Although, I don't know, I'm curious to know how that splicing compares to the figure 8 on a bite. It's like
it's way better.
It doesn't seem like it's worth the effort. It seems like it's so tedious. I get that.
No.
I guess it looks a lot cleaner.
Do one right now, but I'm not quite ready. But man, it takes like 2 minutes. You'll get good at it. Yeah, this is. I mean, like kite surfers. This is like if a kite surfer can do it, you can do it. Yeah. So, anyways.
Yeah.
No, it's really quick. I'll either do like a demo video, or maybe we'll do this another week. But like,
I've got to buy some bigger ones. Do you reckon you could do it with like a 0.6 mil string?
3.55. Yeah.
I think that's what I've got.
Yeah. So I haven't spliced that
Oh,
one yet, but
apparently
it's
0.8.
the
That's what I've
16 braid stuff. So you end up with kind of a hollow tube. But yeah, there's no issue doing it. The tool that you need is like, I think I sent you a link to the video. There's like a wire that you bend over on itself. Here.
Believe me, I've got one of those. I don't even know where this wire came from, and I'm a bit worried if I lose it because it's my only one that I've got. But yep.
Yeah, piano wire or something. You can get it, but it's anyways.
Yeah. All right,
Yeah,
I'll give it a go later today and
it's,
report back.
the first one will take 10 or 15 minutes, and
Yep.
you'll be like trying to figure out. But the video I sent you has like a pretty good technique to set the length right. So where you fish it through ends up producing like the top of the belt is in the top of the loops in just the right spot. So you can set the length really accurately. I did find that there's like a correction for as you run it back through itself, it gets shorter because the outer part that you're looping over gets bigger and the whole thing kind of Chinese finger traps down a little bit. So I did like 3 in a row and measured the length that I got and made some adjustments. So you can make the produced line pretty good, but the creep is kind of an issue, and it's a couple of reasons. It's like initially it's like the line needs to kind of set where it wants to go, so it looks like creep, but it's actually like a reversible, like all the lines are just kind of settling in where it wants to go.
Yep.
And that's a lot. So like really what you want to do is like go hang like a 5 pound weight. I'm trying to use non-imperial units, 5 kilogram weight or whatever. Just like let it for an hour or a few hours or overnight, let them stretch and it's kind of set in. And then it should like actually creep, like from a materials perspective, much, much slower than that. And I think that will be much less of an issue over the life of Jugglebot, particularly if we're not like pre-tensioning it super high. Like the less tension that we need, it'll also not creep. So I do think that it will not be the biggest issue. And if we can use bigger line, that'd be another way to use it. So
I don't know if you've seen on Zulip, but I have done a bit of creep testing actually as part of another video that I am yet to publish. But it's on the stream now. It might be a bit of lag, but yeah, I tested a whole bunch of strings, that big bag of strings that I've pulled out a couple times, and my method for this methodology was to hang a 5 kilo, approximately, more or less, weight off of each string, and I left it for a full week. I should have probably been taking measurements throughout, but I just took one at the start and one at the end. And yeah, the Dyneema wasn't amazing. It was like 3.8% creep. And there are other strings that I've got that do creep a lot less, but I do wonder how they would go with they're not quite as strong, so they might break a bit more quickly, and they might be a bit more frictiony, so they wouldn't run quite as smoothly. But yeah, it's definitely not the worst one, but it's far from the best, that's for sure. Yeah. That's the pink one for anyone watching. Yeah.
So I think by having a nice way to tension the line, this problem also kind of goes away. So if you just up the line, feels about right, do half a turn, then this really isn't a big issue, and you might have to replace the line at some frequency, but I don't know. It shouldn't really be a big issue.
It's a lot easier to string up than the linear actuators, so that's fine. As long as I don't have to do this 12 times, I'll be cheering.
Yeah, it should be pretty good. This actually goes together pretty easily. So I have this motor mount. It's all printed. This is me being a little bit cute with trying to print the whole thing. So these are actually like the heat set inserts, and that's holding so I have a ring lug for the electrical connections on the board. I can actually show the O drive. I don't think you necessarily need to do this, but I thought it was fun.
I did see those, and I was curious as to what's going on with them. So that
would make more. The O drive is sitting on top, but
is that going into the terminal block, so you can like clamp on the wires?
There's no terminal block. I just have the bare board. So
Oh,
there's a hole, through hole, and there's like a bare surface. So the ring lug sits on there. Fastener goes through, and you tighten the fastener. It ends up being really pretty slick. And it's plastic, so then that doesn't short the phases and the high voltage bus. So I don't know. It's kind of cool. It's not aluminum, so you don't have a heatsink. But I don't think the board's going to get super hot, but I guess we'll see.
I've actually been surprised by that.
Side.
I've had times when the O-drive was quite warm and the motor wasn't, like with the same hand motor. Although I am running a 48 or 45 volts, so that might be adding to it.
Maybe, I don't know. Yeah. I haven't been monitoring temperatures, but I also haven't been like pushing it for long periods of time. So certainly something we need to look at. I think keeping this heat sunk well and spreading heat, and like the motor's kind of buried in here right now. So maybe some kind of fan, but also I think just by making this big enough and having aluminum spreader, this could probably be enough to get the heat out of here just fine. Let me section this. Talk a little bit about what's going on here. And I did pull this into the rail, so the string actually follows the rail. It's like really tight to the rail, and you'll see in the platform as well. The reason for that is it has to slide underneath this mount. But it's just, it's hanging out much less than the other design, which I just didn't really pay attention to.
So the string comes in from like behind the spool for this view.
Yeah.
Yep, nice.
Yeah, so there's like a 1 or 2 millimeters between there.
Yep.
Just enough room for the line to live in there, and it can translate out to the edges as well. I think there's enough clearance. I haven't fine-tuned this yet, but this is pretty close to done.
You're not using the thread on the spool anymore?
The through hole, or what do you mean?
I remember on an earlier one, you had the thread running around the outside of that spool for the string to sit in.
I played with that. I think that was one of my hopes, that you could use kind of the printed one's kind of rough. If you like maybe the better resin printer or something, but what I was actually thinking is a metal fastener, like a steel bolt would be really good. And it would follow that groove, because it's like really concentric, really even, and like a nice surface and a V that would give it a lot of friction. So I think that's a way to get that like non-terminated tied to the spool to work with increased like load capacity. But I do think we're on the right track to just put a cross hole in here, figure out the right way to terminate it. And I have a few more ideas cooking on like slick ways to do that. So you want the string to like a fishing hook kind of knot or something, like that's not ever going to slip. And then you wrap it around each end of the spool, take it up around to the hand, and terminate it out there with the splices. And this should be really pretty rock solid.
So to clarify on this, that is effectively breaking the string into 2 strings, right? Where on either side of that knot, like there's no reason, as soon as there's a knot or like a fixing point on the spool, there's no reason why those strings need to be the same string anymore, because that knot is stopping them from sliding the whole way through. Is that correct?
That's right. It doesn't need to be, but it can simplify making one long length, put the splices on the end.
Yeah.
What I'm picturing is there's a knot, like maybe you fold it in half and go through the cross hole, and there's a couple of knots where you basically like tie a knot to the spool.
Yeah.
And then it doesn't have to be like super strong, very nice. Like you just need a way to tie it. Like it could just really be like tie it with the figure 8 knot through the spool, and then all the wraps are what's actually taking the load.
Yeah.
It's amazing how much a knot will like slide with the slippery dynamo.
Yep.
Really
I have a lot of experience with climbing and abseiling or rappelling for you USs, but I've seen a lot of that in action.
Yeah, exactly. So that's what I'm thinking about, that eventually it's going to kind of wander away from where we set it. So a nice knot that's got a lot of twists and friction, just like the splice. The way that actually works is it's going down into itself, and it's just like Chinese finger trap. Like there's all this length and surface area. It's kind of clamping on itself. So that's why it doesn't slide. It's just like the spool, like it's wrapped around a bunch and it won't slip because of that. So you need something like that on the attachment in the middle, and that should be rock solid.
Yeah, because my thinking, like I've had very good experiences so far with doing a similar sort of end result where the string is fixed onto the spool. And the way that I've been doing it is by putting a hole through that is perpendicular to the spool axis and offset from the center of the spool just a little bit. And then I pass the string through, tie a figure eight on a bite or just whatever loop you want, and then pass the like tail part of the spool of the string through that loop. And then you pull it and it is on. Like that will never ever ever come off. Which might be a little bit tedious if that needs to be like length precise, but I don't know. I'm also like there's a really nice knot that I'm a big fan of called the Alpine Butterfly that puts a loop in the midspan of the rope or string, and I'm wondering if that could be good here because we could pass the string through the hole through the spool, pull it out through the end of the spool like on the left on your view right now, and then attach like a little hook or something onto that we could like pull out or push in to give like a little bit of extra length adjustment if we wanted it, or even just like hold onto it so that it can't slide around anywhere.
Yeah.
But I guess at the end of the day, as long as it's like a nice fat knot.
Yeah, something that's not going to slip. So that's a problem, but I think it's very solvable. So I think that's the right answer. And then you need a little longer spool, but this will work.
Yeah, having it attached on the end is good.
And then additionally, you have tons of wraps. So like it's also not going to slip because you have like 10 wraps around the spool. So like that together is going to make this like totally solid.
Yep.
So mechanical design here. So
a bolt or like how are you actually attaching the other end there? It looks like it's free hanging, but I'm sure there's like a bearing and bolt.
Well, yeah, so this gets a bearing that's slid in here. It's not in this model, it's in the other test stand model. And then there's a 4mm pin that goes in here, a dowel pin. So I print the spool, and then it's a little bit undersized, so I leave like 2 to 3/10 of a millimeter on the diameter, which always prints the hole small anyway. So I think I just printed it nominally and it ended up small, so it wouldn't fit on. I did try printing the thread, but that's a disaster. So probably like the machinist in me is like trying to like, anyways, I wanted it to work, but it's not possible with even a nice FDM printer to get that to work. I tried it,
especially with that thread. Like that's a small thread.
Yeah, this is M5 by 0.8. So yeah, it's just the feature size and like, and I was even just like trying to be very generous with the tolerance, and it's like a lot of friction, but also not much of a thread anymore. And anyway, it's not good.
Have you tried just screwing the thread into the bare plastic with no thread?
Well, I've had
a lot of success with that.
Kind of form its way in there, but I think so. What I did is I got a couple of tools. So I have a reamer to close fit on 5mm, and then I have the tap to tap this into the plastic, and it's like awesome. So you end up with, and it like because the 3D printed plastic is kind of all over the place, it ends up kind of averaging that out, and the concentricity and run out of this ended up being really quite nice. So I was just pleasantly surprised with how well that worked. So this is supported well, this threads on. So I think that by itself would be enough to hold it on as long as the tension is tightening it. But there's no other like retention other than the string tending to tighten it. I think I would probably augment this with like super glue effectively, to put that on more permanently if this was gonna run for a bunch, but for testing I haven't had that come back up.
What diameter spool is that on the outside? Because it looks a lot narrower than my one. Because my one's...
This is 9 3/4, 9.75. Totally a random number that I picked. But yeah, that's...
So after all that calculation of like what the ideal diameter is for that...
Hang on.
Just picked a random number.
No, it's like in the range of like about where the score is best. Okay. So it works. I do want to make some different sizes, and we'll see how that trades off in reality, because I think if you went a little smaller, it would take a little bit less current to like for the same throw height, but there's a little bit more inertia, so then you'd end up having to like accelerate down to catch it. So yeah, like optimizing this makes sense to me that we should play with this a little bit more, but
I agree.
But it's like all you do is swap out this one part, And then like even with the same string, I think you could just add another wrap or two, and you wouldn't have to like make a new string. So I think there's definitely some quick testing we can do to play with this. I am supporting the far side, so I'll put a dowel pin in here, and then this sits in a bearing. So the bearing just presses into this part just by hand, and then there's like a gap between the spool and the bearing. So this just takes the radial load. And I think one of the things that happens when you do this design, you end up with a string out here on the left and down here out on the right, and it will like twist. It's trying to break this thing. So I do think this is kind of important when you start having load out here on the end of the spool and catching hard. So maybe you can get away with it the way it traverses and which way it's wrapping, but anyways, I think this is a good thing.
Yeah, especially like with the aluminium extrusion, like that just fits in there so nicely. It's not in the way of anything else. Like,
yeah, I should have taken it off so I could pick it up, but it's all kind of sitting there in a pile of stuff right now. But it's just really quite solid. Like this is a standalone unit. We talked about the top, the bottom is exactly the same. Like that's the whole thing, and like you wouldn't need, like you could attach this to something and have a linear actuator that's super fast. So I think like as a simple linear actuator with really high speed goes, like this is pretty well dialed in. I'm pretty happy with the way this turned out.
Yeah, I think you should be. It's pretty impressive. It's very good. So one thing that I mentioned in our conversation on Zulip is with regards to moving the O drive off of the motor. So for anyone following along, the O drive that we're using, the O drive Pros, have an onboard absolute encoder in them. And that's what we've got like at the very back of the motor. So there's a motor in there, and then on the other side of the motor, there's a small magnet, and that magnet is a fancy kind of magnet that can be picked up by the onboard encoder. And that works really well, and it means that you don't need to have an external encoder that you then have to make wires for and deal with all of that nonsense. But my concern is just with the weight of this. Like it feels like it's a bit of a clunky spot for the O drive, especially if it's like for the capstan, for a design similar to the one that you've got. It feels like there'd be a lot of weight a lot further down than I would like, because for my current setup, all of the supports onto the actual Juggerbot are right at the top. So I'm thinking it might be better to have the O drive being the heaviest, except for all the linear rails and everything, the heaviest thing that we actually can feasibly move, and mounting that on top of somewhere else that's like in a better supported way, and then using a separate encoder that just goes straight onto the motor. And that would make that whole section a lot smaller. So, but I don't know, you seem to think it's not worth it, and the O drive encoder is pretty good.
I think, yeah, I mean, no noise on that encoder line, like high frequency digital signals like that, you got to be careful with it, especially if it's non-differential. So
yeah,
it's nice to have it on the board from that perspective. I do think routing the CAN up to the motor controller is preferred, because that's a really solid, robust bus, and then you just have the two wires for power. So that would be my preference, and kind of the reasons why.
I think I will stick with it for now, but I'm wary of how much weight that adds in not good spots.
What are you thinking about the weight? Like, if it was here or down near this node, like it's really not that far apart, and with the aluminum rail in here.
Yeah, I guess I haven't put everything together with the aluminium extrusion. Maybe the O drive weight will be like nothing compared to that.
Yeah, it's certainly not light. I expect that this can probably be made to work, but you might find that it's a little bit too heavy overall on the platform, and then we got to figure out how to make it lighter.
Or make the legs stronger.
We start going off and like, wow, you could make this whole thing out of carbon fiber.
Well, I actually got sent a video recently from my brother, which was this kit for making carbon fiber parts yourself at home, and it actually looks pretty good. And I was considering that maybe this topper ring could be a good candidate to give this a try, but Yep. Definitely not a massive concern right now, but a
It's a
possibility.
whole, yeah. I mean,
They made it look
work with
very
them.
doable in their videos.
It is
They
laying
might.
up composite parts, home built aircraft, and yeah, I mean, you can do a lot with composites and even make simple molds and go to town making some cool stuff. Um, it's a different design philosophy making a composite part though, because everything needs to be kind of sheets and be loaded in shear. So this would end up being kind of a box or something like that, with kind of filled in sides. Is kind of
Yeah.
what I picture. So instead of this kind of tetrahedron that's open, it would kind of close it up, or it would want to, and maybe like you could kind of cut holes in the outside, but the way you build the composite panels, you need to, I don't know, it wants to be like a flat part.
Yeah. Yeah.
So at least like instead of the aluminum rail, I can see using like a carbon fiber square tube or like a C channel, and then it's like attached to that out to the rest of the structure. I do think the tubes are pretty efficient.
Yeah. They're quite good.
I don't know. I think overall this is, with the exception of how much weight is in the hand actuator, but like kind of for functional reasons. I think it'd be hard to get a whole lot of weight out of that. It's like
Yeah.
in the actuator in that rail.
And
But
to be honest, like it shouldn't need to be moving around too much. Like the XY distance required for juggling is not a huge amount. So like it's really just like the width of the ball kind of a second time if you're precise enough.
yeah,
And depending on
I
like the nature of the throws that are being done. But I don't think there should be insanely high accelerations being done on the hand yet, at least.
yeah. So you always be able to do something, and then if you need to do more and like bigger lateral moves between, it might start stressing the linear actuators. And I do kind of wonder like, yeah, where you're at in terms of how much you can move the platform around and obviously how fast, but you'll be able to do something. So might as well get this together and try to get it juggling. Um, so there's this cool little mount. It's a little square. I think you can polish this off if you want, but I have a skeleton to kind of lay out where the tubes go. So these nodes are just random points out here about where I think they need to go. So that's simplified, but this is pretty well done up to something that we could build. So the tube just goes into the socket and it would glue in as you assemble the whole thing. And then there's just 2 bolts on each side to attach it to the rail. There's a slot that you can route the string through, and I think it's wide enough that would work end to end on the spool.
Yeah, nice. I like
And it's
all
the
of that
same.
except for the glue. I would definitely be changing that for bolts. So inevitably, when it needs to be changed, I can actually take it apart. I have had dozens of carbon fiber into printed part things where I've thought, I won't need to change this. It's done. This is it. And then 6 months later, I have to come in and try to figure out how to separate them because I need those tubes because they're not cheap. And it's always a nightmare.
Well,
I've broken my bloody shelf unit behind me because I had to like clamped in my clamp and I was like hammering away at it, and then the shelf gave out before the printed parts separated from the tube.
Yeah. Well, I don't know. You'll have to forgive me. I think that would be like the most efficient, rock solid, and like it shouldn't come apart. It's a permanent assembly. But yeah, if you're making a bunch of iterations, then totally understand. And I printed one,
nice.
and it printed super nice. So that tapers enough that there's just like a little bit of overhang inside that you'd either have to clean out, so the tube wouldn't quite fit. But I also think you want this to be oversized. So if you do glue it, you kind of want a little bit of a glue gap. I think you can modify that a little bit so you end up with a flat ceiling that's a bridge, kind of tear that off. So then the tube should be able to slide right in and fill with glue. But that's just how I would do it. I don't know. Thinking in terms of making it a nice, solid, stiff structure is the primary reasons why.
So is this set up as it is right now? Does that have the hand is not in the center, is it?
And I said I would, but I didn't move it yet. So the reason I even offset it in the first place was just to make this parametric. So I have like the length offset for the hand, and like basically it starts from where you want the center stroke of the actuator. So all we'd have to do, I won't do it live because I'm sure it'll blow up.
Yeah.
But you basically like, where do you want that? Where do you want it positioned vertically? There's an offset for the hand to get out to where the hand is. And then so you can, this will morph around to put this where you want. So it would be trivial to back this up a little bit and put this right in the middle and shorten up the hand to put it in the middle of the platform.
Yeah. Yeah.
I just think structurally it starts to, like, you end up with long tubes here and short,
Yeah.
more tubes here. So it's a little bit of a compromise. And you do need these to kind of get out of the way of the hand. So you have a little bit of clearance there. From the top, this forward tube ends up being plenty out of the way. So you can kind of drop down between there. Yeah.
Yep.
So
Yeah.
I think to take this, you wanted to build one of these, I think most of that's pretty well ready, and you wouldn't necessarily have to like remodel in SolidWorks. We could like agree on what this skeleton structure is, and then you could import this back into SolidWorks if you wanted to, and then you'd want to design, basically make this part, but with attachments that attach to the tubes that we agree on. And these can move around and have offsets, whatever is needed. The only major difference is there's only one tube instead of two coming up from the top.
Yeah.
There's a new one from the bottom.
And the angle that's leaving that part at is a bit tighter as well. I like the orientation that I'm printing those at is pretty obvious. And my printer can't handle insane overhangs, so it might struggle. But yeah, that's definitely solvable. Yeah. My biggest hesitation now is just the time it would take to swap over to that, like, because I would have to buy the tubes that fit that. I have like 0 spare carbon fiber tubes, and like the rest of it's already on. If it could just like into those 6 carbon fiber tubes that like go up to the yellow part in your model, that would be primo. And that's my intention in the rest of this stream, is to basically do just that, like take your design and make it fit that ring.
I mean, part of the issue is I think you'll have, like, you can move this up high enough that basically this clamp gets integrated into your rail here. So if you wanted a quick modification to just replace this rail, take this profile and this pattern and basically add it. I mean, for that matter, export this and put it in as a step file and then chop it up and morph it into this part. Do something pretty quick and dirty to just kind of shove it in here and see how that looks. If you want to just get that profile or just grab the sketch, but however you want to do that. And then
similar to what I'll be doing.
The bottom is will be a little bit different because it'll be offset up. And
I'm thinking for the bottom, especially for now, while I don't have the long linear guide rails, so I've just got this 250mm one. I'm thinking for now, I'm just going to leave the bottom end hanging in free space.
I think you're going to need to attach it. It's
eventually,
probably, Well, I think to even work at all, if it's just free hanging and you have the ball offset, when this accelerates up and down, the bottom of the hand actuator is going to swing around. So I think at least make kind of a bracket like this that has like bolts in it or something to tie the strings to and do your strings out laterally. I think you will want that.
I want to give it a go without that. Mostly because it's less effort to do that, and like if I need to, like whatever change would need to be done to hold the bottom of this actuator would, like, it doesn't really matter when I do that. I can always do that after I've already tested and found that it doesn't work. Or we can test it and find that it does work. Maybe for like super high, like if we're going like 10 meters, maybe, but like there's a lot of stroke. And yeah, watching your video of the ball, of the thing throwing, it doesn't move very far at all. It definitely doesn't make use of, from what I remember, it doesn't make use of the entire stroke of the actuator. So
and part of the reason why is it has to decelerate so early because of the way it's tuned. That's what I mean. Like you need feed forward to keep convincing it to accelerate towards its imminent death at the upstop, and then you got to slam on the brakes and pull it back down. So that's one of the next steps, is to convince it to go faster as it approaches the stop. I don't want to command it past the stop and then come back. Would be the other way to do it, as like a quick test, but trying to avoid it crashing and breaking everything if we can.
My clunky approach to doing that was when I was using the trapezoidal trajectory mode. I just had the deceleration like 5 times higher than the acceleration, so it could accelerate super fast, and then slowing down, it could get to like 75% of the. Well, I had no way of actually measuring this, but it feels like it gets a lot closer to the very end before starting to slow down, so it can actually like reach a higher speed.
Yeah, the trajectory generator will work. I think as you start running out of motor current, I guess I'd worry about it kind of overshooting.
It's definitely not like a long term. I agree that keeping in the same control mode all the time is going to keep things simpler, I think. And like doing all of that sort of control on like the Jetson side of things rather than having the ODrive do it. It feels like that would just give finer control of everything.
I think you're going to end up with like a trajectory generator, all 7 actuators kind of coordinated, and you're going to kind of start here and end here and like smoothly transition to a catch with that velocity. Is like down the road what I think would work really well. Yep. Kind of like we were doing with the splines, but more like a more complete trajectory generator, jerk limited, all that stuff to kind of and minding the work envelope and limitations, that rate limits on the actuators and all of that, to make sure it ends up where you want when you want.
Yep.
I don't know how to program that. I know what it is.
Therein lies the problem.
I've at least started thinking about it again, which is half the battle.
Yeah. Actually, there's one other thing that I want to mention before I forget, regarding CAN and the CAN handler class that I referred to in the Zulip message. That should actually be pretty easy. That should be pretty ROS independent. So I've got like a CAN handler class and then a CAN handler node. These are separate scripts. And the CAN handler node is the ROS one. So that basically like goes from CAN to ROS. But the CAN handler itself it doesn't. There are a couple ROS things in it because I'm like using the logging, but other than that, it should be pretty easy to just like take out. Hopefully, I don't know.
Yeah, I think I could get that to work. I've never done like a real-time Linux or something like that to try and convince it to work well with low jitter. Like, what are you thinking in terms of like what platform to run that on?
I would strongly recommend using a Linux computer. You can't use the WSL, whatever it's called, the Windows. I can't remember what it's called. The Windows like where like VMs Linux. That doesn't work because you can't access external devices.
Yeah.
I didn't know about it until I'd like gone through all the like a couple tutorials, like getting it all set up. I'm like, cool. I feel like I'm kind of getting the hang of it. I can like apply this to my project. And it's like, no, you can't use external things. Like, well, fucking uninstall all of it. I don't know it. But yeah, a Jetson native device is, a Linux native device is pretty useful.
But not real-time modified kernel, just the regular kernel. Okay, yeah. So there's a handful of things like Linux CNC uses this. Can't remember the name of it off the top of my head, but it basically makes it like software real time, where it's pretty good and not like what can happen is like some process like distracts the CAN handler, and then you end up with like 30 milliseconds between commands when you're trying to command it 100 hertz. Yeah, I think it's probably pretty good, but if you're trying to like the acceleration time of the hand is like 40 to 50 milliseconds. So like you definitely, if you're trying to like profile and do this smoothly, we need a handful of points, maybe 10 points in there for it to work well and push it really hard, I think. And make it repeatable on the velocity that you're hitting is the other thing, because we don't want it to just like open loop and kind of it will, like, as you're moving the platform around and stuff, then you're not going to get the right throw height. Like, probably be pretty close, but I think we want to get this thing kind of following the trajectory, get to its velocity, and then slam on the brakes, and that puts the ball right on the trajectory that we want.
Yep. Yep. I think it's worth keeping in mind as well that I am fully expecting to need or to want to add the laser gate and an IMU onto this rig, and I particularly like the aluminium extrusion for this because I can just mount the IMU directly onto like the linear axis of the hand, as well as the teensy to do all of the CAN communication stuff. Yeah, I'm fully expecting to want to add those to add a little bit more like direct measurement of what's actually happening rather than just relying on the like open loop effectively control. Yeah.
Yeah, definitely. I can see sensing, whether it's vision or like with cameras or something like the laser gate would probably be helpful. But
Yeah.
also, like, if we get this thing pretty precise open loop, it may just about work without feedback for some throw heights. So which would be pretty
pretty
cool.
damn cool. Yeah. I really like I've become quite fond of the laser gate idea because it doesn't require anything external. So I can just like put Jugglebot in a room and it's fully self-contained. It has everything it needs. I don't have to like worry about tripods with cameras or anything like that. And open loop control is obviously the same thing.
I think the cameras would go like kind of down on the platform is what I was picturing. So you need,
but having
like,
them move makes it so annoying. And like if the thing's jittering around and the camera's not going to focus.
Fixed cameras on the base
On
below
the base, yeah.
below the motion platform.
Yeah.
So it's a little tricky because your background might be something, but if you have like a white ceiling, like this ends up being pretty good at, like, you see the balls moving around, and you need enough base so you can get their height as well.
Yeah, and all the robot is in the way. I don't know if you remember that. I had a whole saga at one point doing that. Like I have some depth cameras they're okay. I mean, I haven't really used them enough to get like really good results out of them. But I had this whole thing of like mounting this on exactly as you're describing, on the base, out of the way. But it's pretty tricky to get it to make it stay out of the way enough that the robot itself won't be blocking its view in different positions. This kind of like makes the juggling a lot more 2D. So I've mentioned in Zulip a bit that something that really irks me about human juggling is that everything is extremely 2D. As soon as you move out of the plane, it just gets so much harder to like gauge where the balls are and even to catch them, because like when your arm is extended or fully back, that motion is a lot harder than like this motion. And yeah, having the camera on the base for the current version of Jugglebot feels like it makes everything a lot more 2D, because if the robot moves over the camera, then the camera is not going to see nearly as much.
Well, yeah, so they kind of have to look up, maybe 2 or 3 of them around, but they have to be kind of out and up so that they're kind of out of the way, and then you can track.
But they also don't need to see the whole thing. They only really need to see the top. Like when I'm doing, like if I'm practicing 6 or 7 balls, I absolutely cannot see my hands. Like I'm looking up. Like anything below like here is gone to me. So you don't like, you only need to really see the top of the ball path.
You might, yeah. I think you could probably mask, maybe even dynamically, like what you're not even trying to track. Like, you know about where the ball is, so that kind of feeds forward into the, like, where are we looking for a ball, and it's just trying to measure where that ball is. So I don't know a whole lot about optical tracking, but I can kind of foresee, like, I think you can basically do this with cameras only and not any other sensors. And you may not even need them for very much. You just kind of have to pick it out a couple of places and tune the catch location and time. Yeah, I don't know. I'm looking forward to that phase when we're fine tuning it. It'll be fun. So I'm gonna have to. Any last questions or thoughts before you?
No, I think we've just about covered everything. So yeah, I'm gonna try to copy your design as much as I can, replicate it so that I can fit it onto this rig.
However you want to do it. Yeah, I mean, the model's there and shared, and it's kind of a testament to like the cool thing that Onshape is. So
I know. I am very keen to swap to Onshape eventually. I would love to be able to have this sort of working session where I'm like doing the CAD and anyone can just open the link and like move it around, like see what I'm doing themselves on their own screen, obviously restricting edit access, but Yeah, I think that would be so cool.
Mm-hmm.
But I just need Onshape to reply to me to set up a
Yeah,
sponsorship. That'd be
definitely. But yeah, however you want to use this, and let me know if you want. I can contribute to tweaking some of the designs, or if you have any issues, let me know. Happy to do what I can to help this thing come together.
Thank you so much. This has been an unexpected but a very welcome I don't know, experience of having you contributing to this. It's really good. I like the direction that this is heading in. I'm a big fan. Cool.
Yeah.
Thank you, John. I really appreciate you taking the time to do this call.
Mm-hmm.
And maybe we'll see you again next week if the stars align.
Yeah. Chat again soon. All right. Thanks, Harrison.
Enjoy the rest of your day.
Okay. You too. Bye.
Bye. Cool. All right. Let's get rid of this. Don't need that anymore. All right. Let's get cutting. Get rid of Albie's nose. Replace him with SolidWorks. I found that extremely useful, for one. I am very appreciative of John for everything that he's done in this project. He's been very helpful, like particularly lately. All right, so our goal for now is to copy. My Space Mouse is working again now, thankfully. We want to copy the linear rail part of things here. And to be honest, I might. Oh, he's got a. See, my O drives have the enclosure around them. They've got this nice box around them, and I was very happy with myself plodding along. I bought 10 of these O drive Pros, and I was a bit too keen with like getting them all in their boxes. I'm like, oh, I've got 10 boxes and 10 O drives. I'm going to put all 10 in their boxes. So I want to definitely keep with the box, so I don't have to take one out. So I'll have to modify that a little bit. I'll probably definitely derive inspiration from this very heavily. Let's get rid of that. Yeah. Okay. All right. So we can start a new folder. This is exciting. I love starting a new folder in my. Look at this. We're up to platform V6 in Jugglebot V4. This is a tricky thing. A couple of people have asked me throughout the years, like, what version of Jugglebot are you on? And I'm like, how do I answer this? There's like so many different subsystems that all are on various versions. Let's call this copying John. So we will want the linear guide and the linear carriage and all the O drive stuff. So that's that one. We want the platform template. We want the upper node. We want the O drive. No, we don't want that. We want this. And we want this. And we want this. And we want the hand, of course. I think that's it. It's like half the bloody model. Cool. All right, and let's get some music going. I need some tunes for CAD. That eventually loads. All right, so we don't need the pulley anymore. That can go away. And yep, that looks good. It's doing this like, I swear half the time when I open SolidWorks, it's like, oh, I'm going to connect to the 3D Experience Cloud, or whatever it's called. And it just doesn't work. SolidWorks, I've said it so many times, but I'll say it again. SolidWorks, the program is so good, but my God, everything else in the background is so shit. All right, start a new assembly. For some reason, my music's not loading. There we go. Let's go for some staff pics. Hopefully you can hear that now. As always, if you want the volume to be different, then let me know and I can change it around. Oh, I'm not logged in this time. Alright, it's going to have to go away for a sec. Alright, we'll change it a little bit. Cool. Okay, now we're good. So we've got assembly. We want to add some parts. We can start with the frame template. And actually, probably just want to add most of it. The upper node, we want the hand, we want these. I know that the correct way to do this is a little bit different to what I do, but I just can't get out of my habit of doing this, where I like to add, like, whatever my like sort of foundation model is, I'll mount that in my assembly. So the front, top, and right planes are all coincident. I know there's a way to do this so that when you're adding the model in the first place, it will do effectively that, but just have it fixed. But I don't know. I like my method. It works. So now this guy can go in. There are some broken references in here. This is actually something that I would be curious to know if there's a proper way to do this, where whenever I import, it's like this model refers to this frame, but in a different assembly, like a different version of this frame, because I just copied it out into a new file. I think if I was using Onshape, I could do this where like the frame is its own thing, and then I can just like refer to that same frame from a bunch of different reference points. But it's a bit tricky to do that in SolidWorks with like my file management in the back end, because then things are in the wrong folder and it's not as clear to me when I'm just like looking through the folder where everything is. But this means that whenever I import these parts into a new assembly, like what we're doing now, like creating completely from fresh, all of those references are broken and I have to go in, delete them all, and then recreate them all after deleting them all, which is a bit annoying. I won't do that now because I don't really need to do it. But if anyone knows of like the correct way to do that, I would love to know. Let's just get everything mated properly. Yeah, that's right. The way that I've, don't judge me too much on this first little bit. These models have been through the ringer. What? No. I'm pretty sure that's right. What? Oh, it's the same part. Why can I not select the midpoint of that line? Whatever. That goes on there. That is not right. Oh, it's twisted. Front plane. Oh, whatever, let's just do this the lazy way. I'm not expecting to have to change these, the frame or this upper part, like the structure of it. I really don't want to change that, so I'm just going to make it so that I can't without breaking things. So let's just fit these in here. Cool. Sketchy, but good. And we also want an aluminium extrusion, which is exciting. Let's save it first. Having SolidWorks crash is no fun. think I have a model for an aluminum extrusion. In my bought part models. Where have we got? Definitely got one somewhere. Let me quickly find it. No, just model it again. Make a new one. It's always a good idea. I like to take measurements directly from the thing, but it's nice to have reference dimensions, especially for something like aluminum extrusion, which is a very standard thing. I can get at least the approximate dimensions from this, and then check it against my actual one. So let's do this. This would be cool, actually. I can put this in. Add a window. Look at that. So now you guys can see this, but it doesn't block my view. How good is that? Okay, so we want a front plane extruded. Let's start off with this square that is 20 by 20. We have a hole that is 5. Actually, I'm going to do this as one corner and then just mirror the whole thing. So I want to trim, all that. And actually these two. Cool. And my aluminum is, you know what? I'm actually going to not use that reference dimension because I don't think that's correct. Instead, I'll just measure from my one. So we've got the general shape of it is in, down a little bit, in, down a little bit, down a little bit. I know that I could mirror this, but I don't like using the sketch mirror thing. I don't think it's very annoying to use. So instead, I can just mirror it like this. If I can click accurately. This are equal. All right. Done with that. So from here to here is, I've been like very tempted by those calipers where you can like connect them to your computer and you can just like, I don't know how they work, but you like press a button or something and it like sends the dimension to your computer. That seems pretty luxe. 6.3. Don't even need to type anymore. That would be great. So this measurement I can most easily do across the whole width. Is 7.8. It's tight. Honestly, that dimension probably doesn't really matter that much for me. But whatever. This is the one that I think John was referring to with the linear guide rails slipping in. And I think it will be an issue for me with the 9mm rail because this dimension is pretty much exactly 9. It's kind of hard to measure though. Yeah, 9.4. These guys. You are 1.6. So what's left? That guy's tiny. I'm not going to measure that. Oh, maybe I should. Just for 0.5. Alright, cool. And now that's done. I really should have saved my model of this thing before. So we want this to be mid-plane, and right now 250. Cool. And my one does have a very, very small fillet on the outside, so I will add that because I love my fillets. I'm a big fan. Oops. Cool. Now, save this in a place where I can reference it later on. I swear I have this. Okay. And actually, importantly, my aluminium extrusion is not grey. It's black. It may seem like an unimportant thing, but appearances are everything. All right. So for one thing, we definitely want this extrusion, or this linear guide to be on here. So let's move you up there. Linear guide. Top plane. I think this should be good. Yes, but we can flip it. Okay. And finally, we can mate these ones. Cool. And we may as well put the carriage on as well. that looks good. This guide rail is my current 12mm rail, which is actually not this long. It's actually 250 long. But I do have some narrower 9mm, come on, let me click the 400. I have some narrower 9mm one that is 400 long, and that I think will be a lot better. It'll be very similar to what John's got. But now I just have a little stubby one. And let's also do this. And I'll let it be free. Cool. Alright, so I'm thinking I probably want to attach, let's just see how this looks for now, the back side of this onto here. It's always annoying when my planes are not quite where I want them to be. Oh, but I do have one there. Nice. So I want that plane and that plane. I'm gonna move you down. Guide to 20. I feel like this should be able to move down. And it is underdefined. Let's just test this. Yeah, what? It just doesn't want to let me move it. There you go. Alright, good. Okay, so first off, I really want to move this down. What? How does suppressing mates? What? Saving has made it overdefined. Maybe we could just get rid of the carriage for now. You're just causing more problems than you're worth. Yeah, now I can do this. Alright, so let's put those other mates back with the 2020. Let's go that one to the upper node. That one. And we also wanted this. Why does that not break it? Oh. Can I slide it? Yes, great. All right, cool. So looking at John's design, I do like his top. So let's bring this down here. I do like his tensioning thing at the top. So my original plan was to have the strings be terminated in the hand in a different way than what he's done it here, where I would have like the length adjusters in the same way that I've done a bunch of times before. And I would just have like one length adjuster on the string that goes up and one length adjuster on the string that goes down. But I do quite like his tensioning mechanisms. I really like that, like, for each millimeter that you move this whole frame bit up, I don't know if this can go, for every millimeter that you move this up, it will add like 2 millimeters of length on the strings because it's like going up and down. I think that's very good. It does mean that I would need to tap the ends of my aluminium extrusion, which I'm not very good at. I've done it a little bit before, but it was a bit tricky. But I guess maybe practice makes perfect. Yeah, thankfully, I think with my current linear guide, I won't have the same issue that John's had with its sliding in. I think it will sit pretty flush against the aluminium extrusion. But having a little block at the end is definitely a good idea still to just like secure everything. Down just a switch. Yeah, all right, so let's add that block in. I am very tempted to just like import step files from John's model, but I do like the fact that I like being able to edit them. And I don't think this should take very long to model. So what do we want? I actually want my extrusion to be a little bit longer, don't I? Let's call it 270. So I want to add a little block. That will go in here and just sit around the outside of the extrusion, the linear guide. All right, so we want a front plane extrusion. Let's go a box. And we want a little bit of a profile to sit in. Let's make that, it doesn't need to be very deep. Let's call it like 2 mils. And I can get rid of this and this. So this whole thing doesn't need to be that tall, but I do want it to go around the linear guide. So let's call it 12 for now. And maybe 18 wide. That I'm gonna have to change. Cool. Looks good. Yeah, and we want a hole that runs through there, but we actually want to step it. So we can do a revolved cut. We'll go through here. And I'm just using M3 bolts for all this. So this will be 3.3 to give it a little bit of clearance. This will be 6.7. The head, and that probably doesn't need to be very long, so maybe like 4. Cool, hole. I reckon that's good to insert. Stuff block. I really need to like settle on a proper naming convention for parts. Half of my parts have like word underscore word underscore word, so on, but then half of them are like, I think it's called camel case, where it's like capital letters on all the first letter of each word. But I'm really just, and you can see it here. I mean, at least it's not programming where I have to like actually refer to the file name of each thing. So it's kind of okay in that regard. It just looks a bit messy. Oop. I love this right click thing. This is something that Onshape doesn't have that really irks me. You gotta like, in Onshape, you've gotta like do all of the movements with the triad, which is like this thing that comes up, and you can like the Onshape one. The Onshape one is definitely nicer than this triad. I'll give them that much. But the right click, rotate, left click, position. Whoever thought that up, good idea. Very good idea. Oh, I just guessed those dimensions and that fits like perfectly. Yeah, 0.3 mil, that is literally perfect. Nice. So good. All right, and now we need a little cutout to fit the linear guide. One tricky thing, so like here I've got the model in, I've already mated it in. If I edit this now in just the part mode, I'm not actually gonna know which side I need to do that cutout on. So I personally don't really like editing parts in the assembly context like this because it's just so messy and it's really easy to refer to the wrong thing, even though I know you can do the no external references, but it's still just kind of messy. But I like to do like a quick little sketch just to orient myself. And then I'll hop into the part editing mode. That's enough. Yeah, sure. So I actually probably want that to come off. I want this to like fully encase it the whole way around. So I can move that on the other side and then offset it by 2 mil. I know that the guide is 12 millimeters, so let's make this a little bit wider just to give a bit of clearance. This can go onto here. And I don't know how deep this needs to be, but let's just say 4. I want to offset it by 2.3 and go through all. So that's not ideal. I need to move my whole. Of course, I need to move it in the direction that I did not do the sketch in. That's okay. Oh my God. That one. Cool, so just recreated a new plane and offset that whole bit, and that looks like it's out of the way. Oh, I need that to go the wrong way. 1.7. Perfect, perfect. And of course, it's not done till it's been filleted and or chamfered. I think just chamfers in this one. I found that like mixing fillets and chamfers tends to not lead to the most desirable effects often. Depends what you're doing, but for a small part like this, I think just only chamfers will make it look a bit nicer. And that should print, I guess probably this orientation. And that'll be fine. Cool. Oh, maybe I'll shape this as well. Just to be complete. Cool. That is in. We'll have another one of those on the other end, but I don't really care to model that in right now. So the bigger thing is how to attach the aluminium extrusion onto this printed part. I think I'll probably keep this like, okay, so John's got the whole top part exposed to fit the length adjusting thing. But I guess actually for the length, okay, so for the length adjusting thing, all we need is those, like some length down the side of the extrusion to clamp the whole thing in, so that once we've set the length to be correct, we can really just whack it in there. So we just need a bit. I mean, how much has he got? Oh, inches. This is actually something, if anyone is familiar with Onshape, do you know if it's possible to like change the dimensions of so the dimensions that you see are different for different people, even if they're opening the same model? Because John's set this up in freedom units, and I have all of my personal settings set for metric because I'm a sensible person. But for some reason, like, I don't want to change this document dimensions, because if John's set everything up in inches, then it's going to be all wacky numbers if it's all in metric. But surely Onshape has the capacity to have the same thing be shown to two different people in two different dimensions at the same time. Because I don't know what 1.4 inches is. 35. Okay. So to replicate John, we need about 30 mil over the top, which is actually probably pretty good because that'll give lots of height to, oh, that's exactly 30. That is, wow, okay. Yeah, so this blocky part will need to be changed a little bit to only be exposed to the back, but that'll be pretty easy. Honestly, I can actually take this pretty much exactly as is. So I'm going to want to change these. I don't need the nut on this side anymore. I need a straight through bolt, 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 bolt. Probably have 3 or 4, maybe just 3 for now, connection points. Yep, okay. And actually, because this is all on the extrusion now, previously I had to have this big cutout, like this section in here, so that we could fit the linear carriage, which is currently hidden, so that could slide past. But now that everything's being offset by the extrusion, that should be fine. Although, I really want, so I've mentioned this a little bit to John, but I really want the hand to be perfectly centered in this ring. And I think to do that, let me put the carriage back. We can have a play around with this. Let's just temporarily put this on here. Hopefully the carriage doesn't break all the mates again. Now it's working fine. Yes, it's super offset. I guess I could like shrink the length of the hand by some amount. I don't know what dimension is driving that, but probably not by enough to get it smack bang in the middle. I mean, how much is it off by? So I'm thinking I might want to yeah, 20 mil. I'm thinking I might want to recess the extrusion into this ring a little bit. I think might work. I actually need to quickly go to the bathroom though. I'm gonna mute my sound. I'll be back in 1 second. Ah, all right. I am refreshed, relieved, and ready to cut. Yeah. Honestly, I like the hand being the shape that it is. I think it's nice. I'm going to recess the extrusion by, what was it, 20 mil. Let's just double check that. That axis to the hand. Yeah, 21. All right, easy peasy. So we don't have idler pulleys anymore. Which changes some things. Let's go to that folder. Reference that sketch a bit too much. Probably get rid of that and that and that. Honestly, that part is a lot more complex than I really need it to be. So I'm just going to delete it and we can remake it to better suit this actual application. I don't like when you're deleting things. It like deletes the feature and then you've got to delete the sketch again afterwards. I find that a bit frustrating. All right, but for now, let's actually just do the recess first. So this guy, we only need this to be 20.5 to fit the extrusion. This cutout was intended on fitting the belt through, but is now the string. Milo, how did I learn SolidWorks? I actually did a degree in, let me sound like we're talking fully. I did a degree in mechanical engineering and did a lot of, well, some amount of SolidWorks in that, I'd say. I honestly don't remember being really very good at all in my undergrad. Honestly, most of it's just the fact that I've used it a lot. I I'd be very curious to know if like my computer has saved this information somewhere about how much I've actually used SolidWorks, but I would guess on average at least like an hour a day for like the last couple of years. There are for like since I've been doing Jugglebot stuff, like at least 2 years, maybe closer to 3. Yeah, I use it a lot. Yeah, there are some days where I'll be doing CAD for like the full 8 days. If you are looking to get good at any CAD, strongly recommend getting a Space Mouse. I seriously cannot recommend it enough. I absolutely despise using any CAD without one of these. It is so, as soon as you get familiar with like controlling the model with the puck things, like as I move this around, it will move the model. Once you get familiar with that, which does take a little while, if you're really used to using the mouse and keyboard, it can take a bit of time. I think it took me about a month to get used to using it. But oh my God, night and day difference. It is unbelievable how much it helps. But yeah, short answer, I've just used SolidWorks a lot. And actually there were some really good, what are they called? There's like an expo that they do every year, which I hope that Onshape does as well, because I'm slowly becoming more and more open to the idea of moving over to Onshape. There's just a couple of things that need to happen first for that. But SolidWorks at least does these annual expos, and at least previously when COVID was happening, you could access them virtually for free. And those expos are really helpful with just picking up so many random tips with like, so I use this like radial menu thing now where if I press and hold the right mouse button, it brings up this menu. I don't really use it very much for this particular view, but like if I am editing a sketch, like let's say I want to edit the sketch that this is on, I can select all of these things. So this is how I'm like going to like a circle or a square or a line or like a snipping tool or a dimension. I can just super quickly flick through these without needing, you don't even need to like unselect things. Like I can have this selected and be like, nope, I want to draw a line now instead. And like, nope, I want to draw a circle now. And then like, cool, now I want to draw a square. And like, it's so fast. Yeah, it does. All these things take a bit of time to set up and to get used to, but definitely worth it. And yeah, those expos are really good. So if you, I think that's what they're called, like SolidWorks Expo, something like that. Yeah, I definitely recommend attending those, at least virtually. I don't know if I would pay for it. And I mean, it's in the States anyway, so I wouldn't be able to see it regardless, but yeah, they're really helpful. Maybe we can actually just recess this the whole way and then the string can just run down the back. Yeah, I kind of like that. Let's keep going. 15. Linear guide rail mount. We probably don't need chamfers and fillets right now. They can go away. This triggers me as well with SolidWorks, where it's, if you're deleting something and there's an equation associated with that thing and then you delete the thing, the equation remains and it's like, oh, I've got nothing to refer to. It's like, yeah, what you're controlling is gone, so you should be gone too. That looks good. So how far away is the hand now? $6 mil. Yeah, that's fine. I can just shorten the hand a little bit. Cool. All right, so we need the bolts in here and then probably a third one up a bit higher would be good. I don't really trust this. Like this, I can flex. It's kind of hard to show because like my hand that's holding it up here is not super stiff anyway, but like this whole thing does flex quite a bit. And I think I want as many attachment points as I can get to secure the extrusion to this. So how have I done this? I don't need those anymore. Yeah, 25. Sure. Cool. Actually, I think before I do this, I think I'm going to add that top part on now. Obviously, I'm printing this in this orientation. So this top part that I'm about to add on. Honestly, maybe I don't even need it. So just it would end like that. 2 attachment points. That should be fine for now. He says with great uncertainty. Actually, yeah, I reckon I will do 2, but I'll add some more in the sides here. Yeah, that'll be solid. All right, I don't like this. Why did I not do this nicely? He wonders. There we go, that's better. Nice and flush. Yep, okay, so I don't want that top part anymore. But I do want a plane that is 10 millimeters off of this. And that should take me straight into the middle of the extrusion. So I want a bolt hole that will run through. Yeah, that should be pretty easy, just a revolved cut. I don't really want that folder anymore. Revolved cut. I could do this as one and then mirror it, but I don't really like mirroring. I like having my feature tree nice and clean if I can afford it. So I'm gonna go up, do. Mirrored. So this, as always, will be 6.7. This one will be 3.3. I want the whole length to just be huge enough that it won't get in the way. Or like, that it won't miss any of the model. And this dimension, I want to make sure that I have enough for the, actually I'm not going to do it that way, I'm going to do it on here. I usually have like just 3 or 4 mil, but I want this to be solid, so let's do 5. And because why not? Let's make it concentric with this circle. Cool, fully constrained. Perfecto. We don't need these. This is a bit of a clunky way to do it, but that's what happens when you edit old models and don't make them from scratch. And as always, gotta add the fillets. Your model's not done until it looks good. I would say that is pretty close to looking good. And yeah, I should probably test this before I do all the chamfers and stuff, but YOLO, right? Oh, that looks so good, so clean. Okay, what has broken? I'll do that later. All right, so this is now fixed. Let's copy John's dimensions and make that 30 mil, or approximately 1.4 inches. And actually, let's fix these mates. Easy fix. Very important. All right, so now we've got the string tensioning thing. So I am actually kind of tempted to just take this as a step file. What is it? I really want to take some dimensions, but it's all in freaking freedom units. No, I'm recreating it because of the freedom units. All right, so we'll have a bit of a lip. Yep. Ooh, he's got little grooves in there as well to fit into the extrusion. That's nice. Come on, unhide. Whatever. Yep. Cool. So we want a new part. Let's do the front plane. I'm a big fan of not doing fillets and that sort of thing in your sketches. Keep everything nice and angular. It just makes the dimensioning so much easier. And then do the fillets as like actual proper features later. Should we want this? How has John done it? He's made it flush. I want to make mine a bit more like tapered on the sides, but I'll just do that with the chamfer later. Let's do that as 20. Let's take some other dimensions first. Oh, it's all in bloody inches, I keep forgetting. 2.15 inches. And does this measure between the centers? Yes. 0.8. So we want 2.1 inches, 2 millimeters, and 0.8. All right, so the first one is 53. Let's call it 50. And we want these. I guess I'll probably just use the belt idlers for this. So one thing that John has noted is that when the capstan makes the string kind of like move back and forth, the string, when it wraps around the pulley, let me show you on the model. When the string wraps around the pulley, it likes to like wander back and forth. I don't know why I can't unhide things. Yeah, but the string likes to wander around the sides. So I think it's probably a good idea to use these belt idlers so the string has a bit of extra room. Yeah, I guess I'll just copy that. And that will mean that if we do swap to a belt again, it'll be really easy to swap back. I have no idea how to pronounce your name, aka Dodo. Very nice. Yes, up a bit too late. I don't know what the time would be in Ireland, but it's a nice 1:45 p.m. where I am, and the weather outside is looking beautiful. You've been coming up with wire pulley ideas for robot neck articulation. That sounds complicated. I mean, if you're after some suggestions or anything like that, I implore you to post on Zulip. I've got a channel on a stream on Zulip for show us your projects, and we've had a couple pretty cool ones in there. There was a cricket playing robot, which we may see a video on soon, hopefully, and another steward platform. Someone made a really cool steward platform that, like, right now it's more or less just a steward platform, but his intention is to have it, one of the intentions is to have it so that it can like walk around as the steward platform, which is very cool. But yeah, I'm always keen on string routing things, anything along these lines, I would love to have in the Zulip. So yeah, if you do need any external suggestions, you should post on Zulip. But I definitely appreciate the head being fried bit. Imagining in your mind like the routing of the strings gets very complicated when you're doing it in 3D. Very, very complicated. So these idlers are 18 millimeters for their like outer flange bit, which is what I don't want to touch. And then the inside one, I think it was 12. Yeah, 12. And this is what the string itself will run over. Yeah, Dodo, I reckon you can definitely use field-oriented control and brushless DC motors for sure. That's effectively what we're doing here, right? We're using a brushless DC motor with the O drives, which is field-oriented control, and yeah, to control a linear axis. And it's essentially the same thing I'm doing on the linear actuators for the legs of Jugglebot. So yeah, these are topics that this project knows well. And yeah, honestly, like the linear actuators that you can buy online, not fantastic. I've only ever had experience with two. One of them was like a stepper motor based one, which is actually pretty cool. There's like a through hole through the motor, and the lead screw goes through the motor itself, which is very cool. And then the other one was like some like AliExpress linear actuator, which I don't know, it was cool. It'd be cool for like opening doors and that sort of thing, but not really for robotics. So I want to make sure there's enough of it. Very importantly, there has to be enough of a gap in here that these don't touch. Let's give it 1 full millimeter. And I want these to be, I want the strings, so the string will run down off of here, and same on the other side. And I think ideally I would be like keeping track of that so that the strings are like perfectly parallel the whole way down. But to be honest, for now, I'm probably not going to worry about that. I think if the strings taper just a little bit, I think that's probably fine. And actually I should, see, the thing that really annoys me with these idle is that they're using a 5mm hole instead of a 3mm, which is what I'm used to. So I can't use my normal bolt technique. And I don't have any shoulder bolts that fit that. So I'm just gonna have to go straight onto the thread, which is not ideal. But what can you do? So this is 5mm. And these are all construction. position that? Actually, you know what I can do? I can make a line that's tangent to this and parallel to this. Set that to be like 3. Same thing here. Oh, 60 degrees. All right, I don't want that to be mid-plane. All right, so let's see what that looks like. This will be, I don't know what to call it. This is honestly like a non-trivial part of CAD for me. Is like, what do you name your parts? Let's call it tensioner. And I do like with John's design that this is fully symmetric. So we can just make one copy of this part, mirror it, and then mirror that whole thing for the bottom. That's very nice. How do I get rid of mate connectors? Oh. Cool, so once this is done, we just have the O drive mount, and that's it. Cool, easy peasy. So that edge goes on here. It's always good to use the main planes as much as possible, but it's not always feasible. Cool, that looks good. Alright, so I want a bit of a lip for this to sit into the aluminium extrusion. The question is, can I remember the dimensions I used before? Because they were perfect. This is 45. These are equal. I believe that was 2, and this was 5. Yes, beautiful. And we can probably run that a bit further. 5 AM, oh my goodness. Yeah, get out of here, go to sleep. Mini ball screw actuators are so smooth, they're back drivable. Yeah, back drivability is nice. And the lead screws are cool. They're a bit slow for what I was using them for, but I do like the lead screws. These screws are very cool. Maybe 40 is a bit much. All right, that's looking good. I love just spinning the model around, having a good old gaze. All right, I want to add in the idlers here. Let me see where I've put them. Yes, Ben, I make extensive use of a space mouse. I cannot stand keyboard and mouse controls. Oh, there he is. You shouldn't be black. Why are you black? Yeah, if you yourself don't have a space mouse, I mean, you can just see, like, look at how much easier this is. It's like, oh, what's going on down here? Okay, cool, yep, all right, now what's going on over here? Yep, cool. Like, that operation would have taken like 20 seconds, keyboard and mouse. And if you do that all the time, which you do, then it saves so much time. Why are you not changing? Oh my god. What? I will have to just... insert it here. Yes, that's better. Cool. What did I just do? MX Master. Oh, that's your mouse. You can keep your mouse, like your mouse is the same. I actually use the MX Ergo with the little like thumb thing, which ordinarily I probably wouldn't recommend for CAD, to be honest, unless you have a space mouse. Because if I like, it makes clicking on really precise things a little bit more tricky. But if I'm using the space mouse, I can just like put the space mouse, like I can orient the camera so that my mouse is like more or less where I want it to be, and then just like do a little bit with the rolly mouse. But yeah, no, it's if my space mouse broke, I would buy another one again, literally immediately. As soon as I knew that it was broken beyond repair, I would go online and buy another one, because CAD is just not the same without one. Where's my other? There it is. Alright, and I want these. I've made such messy planes here. And actually, I really like having a mouse that has like shortcut buttons on it. So like I've got one button that does enter. So like if I'm like making a change to something, I don't have to like take my mouse off I don't have to take my hand off my mouse to press enter. I can just press a little shortcut button and it goes. Like literally the only time that I take my hands off of these two devices are when I'm typing something in to like name something, or if I'm entering numbers for like a distance or something like that. All the other time I'm just sitting there like this, just like locked in. It's great. I love it. We want... So I'm trying to find a plane that goes through here so that I can mount these pulleys without having to reference stuff that I might be changing. So actually probably my extrusion. Yes, that plane. I want to make that symmetric. That. Cool. Always got to save in case SolidWorks crashes. Okay. So I think the next thing will be... Oh, I'm gonna have to move that over. If I'm gonna copy, so John's approach has a tensioning hole in the middle here, but I think I'm gonna have to move my pulleys a little bit to fit that in, because as it is right now, that hole is very much covered up. Ben says, yeah, I've got macros for escape and enter. Yeah, I know, it adds up. Like it doesn't, it feels like a little bit, I don't know. It feels like it's a bit too much effort than it's worth when you're setting these things up in the first place. Like getting all of my like right mouse button shortcuts done took a while, but once you do, oh man, absolute game changer. Let's move these. Yeah, this one's too close. I'm going to have to change this a bit and bring it out. How do I want to do this? Yeah. Honestly, I could just make it fully symmetric. That is tempting. That's not supposed to be like that. Honestly, yeah, I'll just make them the same. Why not? Probably don't need this to be too far apart, maybe 15. Let's try that. What? Yeah, actually that'll probably be nicer as well. That looks like completely accidentally that's lined up. So there'll be a string coming up here and a string going down there. Yep, I will take it. Let's do that mate a bit more properly. So I want the front, nope, the right plane of that to go through the 2020. Yeah, perfect. Cool. And honestly, like the Space Mouse, I think it would be worth it just for the fact of like, just being able to like zoom out, turn everything around and go, yep, okay, I see how that fits. And like, I have spent so much time just spinning my models like this and just like having a look at them. You can really, you just see things a bit more differently and you can just so quickly like pop around. So good. All right, let's add some. Okay, so let's have a look at how John's done the tensioner. Yep, okay, so he's got a bolt and the head of the bolt, so there's, yeah, the head of the bolt pushes against this bottom surface and pushes the whole thing up. And I guess as it is by itself, there's nothing actually holding it down, except that you've got like clamps on the sides into the aluminum extrusion. But yeah, I guess that works. But it does mean I'm gonna have to model a bolt. And I think that's 5mm thread. And normally I'm a massive fan of the button head screws, but I do think this is one where it will benefit from using one of these, I think they're called socket heads, the more chunky ones like what John had. Yeah, that fits perfect. All right. Ben asks, how long did it take you to acclimate to one? It's been half my life on SolidWorks. Yep. Yep, you definitely should get a Space Mouse. I have heard from some people that they don't like them. This is like through the grapevine, but I am fairly certain that the people who didn't like them just didn't spend enough time with it. It took me probably about a month, which is, I know it is a long time, but it's not. I have recouped that month handsomely in the time that I've been using this. I have zero doubts about that. Yeah, expect to take a little while. Expect for the first little while to be like, whoa, oh crap, my model's gone. Like, it definitely takes a while, and like getting the sensitivity right. So like when you open it up, if I can find the right thing to do this, it doesn't want to open right now, but there's a whole thing where you can like change all the buttons and like change the sensitivities and like the directions for everything. All that stuff takes a little while, and like getting the sensitivity right is a bit of a, it takes some time, but yeah, honestly, no question in my mind that this has made me a significantly better CAD user. All right, so let's add that bolt thing. So we need a little step for that bolt to catch on that won't hit the idlers. So let's do it off of this plane here. Actually, no, let's extrude from here. I just need to make sure I stay clear of these two guys. I also, so the Space Mouse has a bunch of different models, and I have zero regrets about buying, I can't remember what this one is called. Space Mouse Pro, there you go. Zero regrets about buying this version. I like all of the buttons around the side are similarly important to the puck itself. And they've got a version that's just like the puck and then like two buttons that look kind of awkward to use, to be honest. And they've got like an enterprise version that has like a full screen on it, but I think that's a bit overkill. Although, I don't know, maybe the buttons would be nice. I think that the Pro version is good. I'm a big fan, as you can probably tell. So I want a bit of extra room here, just in case. I probably want this to be like kind of thick. Actually, let's not make that. Let's do it this way instead. And this is only having the bolt rest against it, so I feel like it doesn't need to be that wide. That will go 10. So I'm thinking if I make a plane that is 10 mil off of the front plane, then this will represent the middle of the aluminium extrusion. Why did that circle extrude? So that means that I can mirror. This will be like my final thing, but I can do it now and like just suppress it or revert back. But our music stopped again. Cool. Look at that, coming together. I do like this tensioning mechanism. It's very clever. I just need to make sure I have enough space to fit whatever tool I can use here. I actually don't know what driver fits that. That's actually, there's not a lot of tolerance in there then. So, yeah, the difference between, like, there's only really like that surface that's contacting the plastic, because you've got to get the tool in there to actually adjust the thing. Yeah, let me check my drivers, see what fits. First try. Cool, so I want to fit that in. 4.8, not a lot of space. Going through all there in case I change the width at some point. Perfect. All right. We probably now need a bit of a better way to support these pulleys. So what's a good way to do this? Just like a little tapered like thing that it will rest on. Yeah, all right. This is probably not going to be the most elegant way to do this, but whatever. It works. So I want to be out a little bit. Just do like that sort of thing. So my idler, 8.5. So I probably want this to be like, let's give it 4.5 and that'll give it a bit of clearance. Piece. Probably doesn't really matter how big that is. Just pick a random value. And this, the smallest that I can realistically go is 0.6. I was a little bit worried about that. That's right. Just trim it. Let's see if this works. Come on, delete face. Pull through. There's another one. I love delete face. It's just, there's been so many times where I'm like, surely delete face can't handle this. And then it does. But there have definitely been a lot of times where it actually can't. So I can either mirror this feature, or I think a bit of a more robust way would be to pattern it. And I think I will pattern it. So if I add a point here and here. I think it's probably not like best practice to refer back to old sketches so much like this, but whatever. So I want to sketch-driven pattern. This is my sketch, my select points. That one. Bum, bum. So that works wherever, so the way that that pattern feature works is wherever you have like points in the sketch, they have to be a point rather than just like the end. Like there's an actual specific sketch feature called a point. Wherever you have those points, it will put whatever feature you're patterning down. So I added the points onto the center of these circles here, and then I can just pattern this feature across, which is pretty good. It's a pretty powerful feature. You beauty. It's probably one of the most Australian things I've said so far on this channel. I love that. Easy access in there. There will be a string going across that I can't forget about now because I've already done the same mistake with Bolt, but it should be very easy to access. Actually, since we've got lots of room, I actually might make this a bit thicker. So that will limit how far down this can go. So I probably want that up as high as I can. Is that going to hit things? Ooh. If I just make that a bit narrower. Yeah, easy. I do probably also want to replicate. So John's got a bolt going through the top here, just to like keep these two halves together so that, I mean, it's pretty unlikely anything's going to be trying to open these up, but you never know. I probably want to keep that, but I think I'll just use like an M3 bolt and just go straight into the plastic rather than having a nut. But I can do that on either side of this guy so that I don't interfere with this hole. Other than that, we need the holes in the sides. So let's change the order of these. What? Why does this refer? I don't like that SolidWorks seems to prioritize selecting sketch features rather than like the main features. Like if I selected that point, I'm pretty sure, yeah, when I did that before, it was selecting the middle point of this feature rather than the origin. It's like, why would you ever want to reference another feature over the origin if they're like coincident? I mean, I don't know, I guess maybe I can think of reasons, but origin features are just so much better. So now that I've rearranged this, I can put that all the way up to there. Now, I actually want to add in these holes. No. So the holes that go through this are just having the bolt go through, yes, so that's going to be mirrored on both sides. So let's do a revolved cut. Three, 6.7. Six up from the bottom. Why not? Why not? Cool. And that's a linear pattern that. Probably don't need 10 of them. Cool. Actually, this is very worth being aware of. So the lowest that I can put this, actually, yeah, no, the lowest I can put this, if I'm keeping this all how it is right now, I've got all of this clearance in here, so I can make this a lot shorter, 5.3 mil shorter. Yeah, nice. Keep it all compact. Okay, I think we're at the point now. We've got an important decision to make. Does this part want to be black? Or does it want to be red? I think probably red. I like Joggerbot red. Alright, so now I want to add in the holes to attach these two parts together. What was that? 30. That's perfect. I kind of want for these bolts to be hidden. No, let's worry about that later. Can get fancy a bit later. So I'm going to do a revolved cut, so I want a plane to be in the right spot. Let's change that to be a reference for the main plane. What? I can't scroll that. And I guess my biggest thing right now is that I just want to make sure that I don't interfere with either the idlers in here or this hole, so that I can tension everything up. So let's put that at like 6 away. Should give lots of room. And I don't like the look of the bolts hanging out the end. I like it when it's like nice and clean and contained. But I also want to have as much grip as possible. So, I mean, what is that? 4.5 mil? Yeah, that's plenty. Let's move it up a smidge. And I will be lazy on this one because I don't feel like the asymmetry here is going to affect this part too much if I do change things around later on. The main reason why I did the linear pattern before is that I wouldn't be too surprised if later on we change this and have it be like, rather than being perfectly like Y-shaped like that, it'd be a bit tipped. And I just want to make sure that that feature moves properly. But this one with this just like tensioning bolt, I feel like I'm going to want that to be on either side of this block in any situation. All right, so we have a way to clamp it onto the sides. We have a way to slide it up and down using the bolt that runs through here. Maybe I should just model that in. Actually, I might already have one. M5 bolt. But I can't change its configuration in the assembly, probably because I'm live streaming. There are like, I've noticed like a handful of things that just don't work when I'm live streaming on SolidWorks at the same time. The most random things. Like I have different configurations of that bolt. Normally you can just change them. But I'm gonna have to change it in here. Flip. All right, so that surface will run on that surface. Cool, so there'll be a thread in the extrusion. You can come in here, adjust the bolt that will actually have a head feature in it. Cool. I think it's time to pretty this part up. I think all the functional things are done. It'll be clamped together, it'll be attached on the sides, it'll be tension adjusted. These should fit nicely. Yep. Time to get pretty. All right, I mean, the most obvious one is definitely these corners. These have to go. Kind of hoping I could get that to match perfectly. That's all right. Yeah, why not? Oh, that is actually pretty good. All right. Okay, that already is such a big improvement. Well, we can definitely afford to add some small fillets in here. I don't want vocals. Thank you. Cool, and the most important chamfer, this one's really gonna take us home. I wanna do these ones just for getting the bolts in a little bit more easily, in case the tolerances aren't right. but the big boy is this one. Yes. It is honestly amazing to me how big of a difference just like one chamfer can make in terms of the like, I don't know, aesthetic appeal of a part. Ah, okay. I just realized why that was 35 and not 30 because I'm glad that I modeled the bolt in because I completely forgot that that would actually take up space. So now we can move this up, back up to 50. And this one should be 40. Cool. And of course that would have been mirrored on the bottom. Yep, nice. Okay, so now we need to mount the O drive. All right, let's see what John's done. That is quite a nice piece. So I'm going to model a spool first. So I want that to be, let's just go the same size. Oh, I meant to ask him, I forgot to ask why he's done this hex pattern on the end here. I don't know. You guys have any thoughts? I'm very unsure. It might just be to help it print properly. Actually, no, that'll probably be to screw it on, so he doesn't have to like grab the printed plastic. I reckon that's it. So he's made that 1.293 inches. It's not even a nice number in inches. 33 mil. Let's grab a spool. Here's one I prepared earlier. But that's... I don't remember what this was for. So was it 38? I think. And I've actually had very good success so far with my method of attaching the spool, which I don't know where, I had one on my desk. I think I've just like misplaced it. But I've like basically been having the hole go the whole way through and then having a lock nut to attach on. So where John has, he's like threaded this. Lyrics are a bit distracting when doing this. John's just like threaded this spool straight on. Let me see if I can do a section view. Yeah, through here. So he's threaded this in. I do like that, but I am not interested in like tapping the way that he has. And to be honest, I probably could just go straight into the plastic. But I feel like the lock nut is very, very secure. So I think I'm going to keep it the lock nut. But it does mean that I won't be able to have as small of a spool as he's got here, I don't think. That's what, 0.38 mil, or inches. 9.6 millimeters. Whereas mine is 12, yeah. That's all right. I need to measure on the motor. Because the motors have got this little, like, an unthreaded bit. So I need to make sure I stick with that. Thank you, Microbyte. I appreciate it. So it was 5 mil of like that non-threaded bit. So let's go 6. So that lock nut will go in and grab on nice and tight. Okay, I've just realized why John's way is a good way to do it. Because he has the other end supported by he's got a dowel pin. I think I'm just gonna use a bolt because I don't have any dowel pins. But with my approach, with the lock nut, that will open this up too much. And I won't be able to put a bolt in. So, let's make this, what is it, an M5 thread? Something that's also really tempting is that these motors, there's a little hole in the end of the axle, and I wish that was tapped. If I could like screw into that, that would be so helpful, but it is not, and maybe I should try tapping it myself. Maybe that's worth it. But in any event, right now this is 4.9 mil diameter, so I'm going to make it exactly 4.9, and the threads will grab in, which is maybe a little bit dodgy, but it should be alright, at least for prototyping. Yeah, I like this. So that spool will go on here. Like that. Cool. Oops. All right, so I think the important thing here, I think we really want to make sure that the spool is centered. I think that's probably the biggest like geometric constraint. So let's fix that straight away. And then we can also probably straighten it up a bit. Cool. And finally, we can set the horizontal distance. That one. I don't really know how far do I want. I probably want that to be really close actually. So maybe like 12, too close, 15, too close. Actually, if my spool is all the way out there, yeah, no, we can make this further out. That looks pretty in line. This is all just a prototype for now. Thankfully, these parts will be so easy to change. We can so easily reprint this and just like take it off the end of the extrusion. This whole, whatever is mounting this will be really easy to change. The only thing that will be a bit annoying to reprint is this ring, which is like a 7-hour print. But I don't think I'll really need to. Cool, so everything else can kind of just be guessed. Which I'm a fan of. Okay. I want to do the other end first. I want to support this end first. So I want to use a 5mm bolt that will screw into here and go through a bearing. But of course, I don't own any bearings that are that size. Closest I've got is 6mm. So we're gonna have to change the spool a bit. What is broken? What? Maybe I should have kept those lines. Nope. What is... whatever. What is this unhappy about? Midpoint. That's it. Yep, okay, cool. So this is 5.8 and I want this to grip in solidly, so let's see, 5.9 feels about right. Let's put it there because why not? What do you do? Did I get it the right way? Yes, nice, cool. All right, so on the one side, the motor will screw in, and then the thread, the inside opens up a little bit, and then the other side will grip in. Yep, so we just want a little block that will attach onto the aluminium extrusion, have a bearing for this to run into. That's about it. All right. I reckon I can do this in 5 minutes. 5-minute timer. We want bearing, the outer diameter is 12, so I actually want this to be a fairly tight fit, so let's go 12.2. That's not what I wanted. This is not helping. Let's just do these for guides. So these are the attachments into the extrusion. Probably want that to be pretty solid. Let's give that 30. And this needs to be from there to the center plane of the 2020. That one is exactly 25 mil, very nice. All right. So I just want to trace around this. Up, 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 up. Let's call this 8. Oh, the music ended. It's eating into my 5 minutes. Shit. Quick, quick, quick. Oh man, I've got to say, the other day I was doing Jugglebot stuff. Like it was yesterday when I was like powering everything on. I like powered it on for like, it was one of the first times that I had powered it on since like changing everything over. And like just at that moment, my housemate like turned the tap on, but I didn't realize that that's what the sound was. And I was like, holy shit, what is like, sounded like something was like, I mean, it sounded like a tap, but in my brain just went straight to like something electrical was like failed. And I was, had a real good panic for a second. It was very worrying. I'm running out of time. Should have set a timer. I want this to be, I don't really know how long. I think 15 should do. This is spool support. That's better. Okay, so I want this to have a cutout to fit the spool, and that needs to be, let's call it 10 millimeters. Into the front plane section. Let's just make it a circle. Cool, so there will be a bearing in here, like this, bearing with a bolt passing through it. And that will support that end of the spool. And then this end will get bolted in. To be honest, I probably want to make that a little bit thicker. What is that right now? 5, nah, 5 is heaps. But then these guys can get cut to fit the head of the bolt. Cool. hindsight, this circle was silly. That is a silly, silly way to do that. I think I've gone over my 5 minutes. Hopefully not by much. I'm so close to being done, I just need the fillets. And chamfers. Can't forget your chamfers. Because look, this part's like, meh, it looks alright. But once you add some chamfers in, it completely changes. Actually, I just want to make sure this is 5mm thick, and my bearing, yeah, has a thickness of 4. That should be fine. It'll just be in a bit. Biggest one, this one. Boom, boom, boom. And actually, I do want a little groove for this to like sit in the extrusion properly. I've definitely gone over my 5 minutes. Alas, what can you do? Let's go as fast as I can. Not really. I feel like not streaming definitely helps. This to be above cut. Beautiful. I think I might just fillet these edges as well. And also probably just bring it a bit closer. Although it does overhang there a bit weirdly now. No, that's fine. Cool. That looks good. Now does that part definitely wants to be black. Yep. All right, final part, mounting the O drive. And then this will be copied, that'll be copied, and then we'll be good to print. Actually, no, I need to change the hand as well. Mount the O drive, change the hand, and then we're done. How should this mount? So currently on my existing one, I have mounted the O drive onto the linear guide rail with this there's 2 printed parts in here. There's this back one and then these 2 ribs. And this is super, super solidly on there to the point where I question whether I actually need the ribs. But I think I will make something very, very similar to this, I think, for what we're doing here. Just because it's so solid. So we'll have, oh, that will line up so nice. So we just need like a block that will slide into the extrusion, or like attach onto the extrusion with holes to put those 2 bolts through. And then some kind of rib. Yeah, easy. Espez. I'm not going to claim any time allowances for this one. I've learned my lesson. Although I don't think I was far off. I think that other part was probably like 8 or 9 minutes. I'll be curious if anyone's watching this back. You can time that. I would love to know. But I'm also not really expecting anyone to. So this wants to be 20 wide to fit the extrusion. I think I'll attach the O drive on this end. I don't know right now how long that needs to be, so let's call it 30. And I want the little feature to sit into the extrusion. What is going on here? Ah, these two. The O drive is, I think they're 70 apart. No, 60. So let's make this 70, just for now. Okay. Cool. I guess it would be nice. It would be very nice to be able to adjust this position without having to take the O drive off. So if I make this a bit taller, not by much though, let's just go 80. Maybe a bit more, maybe 90. And it doesn't need to be quite so long apparently. 1 millimeter off. That was pretty dang close. There's no way I was going to guess 29. Alright, so we want holes that are 60 apart. Yep. And then some way to attach it onto the extrusion. and easy. All right. And for these, I know this is probably not the most legit way to do this, but I don't really care because it will work. I'm just going to put the bolt straight into the plastic. Which is 3.9 mil, and so that's the same size that I'll make the hole. These should be exactly 60 apart. Cool, now I don't actually know how long I need these to be. I know the bolts are 30. My marker's running out of 30. But that's after going through the O drives, so I think that'll be heaps, 20 shootloads. Cool. And now we need some way to attach this whole block onto the extrusion. So let's make this fire away from the top. And we can do a revolved cut. Nice, and we can just simply mirror that to get it down the bottom. Cool. This part also definitely wants to be black. All right. I think I want a pretty aggressive chamfer on here. I really want to like taper off. I don't like this. This sticks out like a lot more than it needs to. I hate when this happens. It's always so fiddly to click on that little purple arrow. There we go. That's nicer. Okay. So now we want the ribs. So we got one that will. We basically just want to like make use of these holes because right now, like this will probably be able to wobble like this way, which is how the motor is going to be pulling it. So we probably want a rib to like connect this hole to the extrusion just to support it a bit. Yep, that should be pretty straightforward as well. Let's take some measurements. From here to here is 50.17, 50. And then from here to that plane is 39. It's 1539. So that's this one. It's 50. This one is 39 to the middle, but I want to have it a bit wider. So let's call it 45. Just kind of picking random dimensions. very tempted to make this a bit differently, but it's alright. Later after 2020 rib. So we want this hole to be coincident with this hole. Nice, that was good-ish. Is that deep enough? Yes. Alright, now we just need some way to attach this onto the extrusion. I can actually probably afford to be a bit wider. 4 mil, 49. I don't want this to be too ugly. You know, aesthetics are important. So this is down here. Why not? So I want my hole to go through. Hang on, I'm getting all disoriented. So this is going that way, and I want my hole to go through here. Which is through here, yep. I don't like that, I guess there's not really any other way to do it, but like whenever you start a sketch and like make it normal, that normal direction is not always where you expect it to be. This will be 10. And yet another 6.7, 3.3. So I'm like almost to the point of like making a macro just to enter those numbers and hit the enter key. All right, and we want this to have a bit of a groove to sit into the aluminum extrusion a bit better. So we can go up, across, down, across. Pretty happy with that. I don't know if I really like that this lip is here. I mean, how far actually is that? It's only 1mm, that's fine. Actually, no, we can pretty easily fix it if I just make this a bit thicker. There we go. This is also definitely black, no question. All right, now let's pretty that up. Get us some chamfers in there. Yeah, maybe do it separately. Oh my god. No. Kind of, no, that's fine. Let's also do the bottom side as well. And actually maybe we'll fill it. This guy. Nice. Cool. I don't really want to model in the other one right now. Oh, I'm gonna do it a lazy way. What? Oh. I really don't, that is the one that I want, but I don't want to do that one because that makes a new part. Oh, actually, shit. It does need to be. I'm actually glad that I did that. I was just going to print off the same thing twice, but no, it actually is mirrored. So we want to create a configuration. Nice. Yeah, nice. All right, I guess in the same vein, we may as well mirror all these bits just to have the full model. So we want to mirror this and this and this. And they shouldn't need any sort of reversing or anything. Yeah. Oh, and also actually the block. Perfect. This looks very funny with such a short linear guide, but once I get a longer one, this will look a bit more normal. All right, last model, last piece, the hand, which, let's see if we need to move it a bit. I think we did, it was like a couple millimeters off. 6.5 millimeters off. So I want to just bring it a little bit over. Problem is, I don't know where I sketched that. What is D1? Ah, here. Fuck, I can't remember, what was the number? 6.5? I think it was 6.5. So it's 22.95 minus 6.5. I don't like leaving things as like driven equations, because then I'll look back on this later on and be like, why did I make it that? Okay, so that should put those pretty much, yeah, 0.01 millimeters. I'm happy with that. All right, so now the final thing is to attach the strings. And John has done this. I quite like the way that John did this. I think I will copy it. Where is it? Here. How do I... I swear there's a button for like hiding everything else, but I didn't see there. No, what? Oh, it is that, yeah, okay. Yeah, so John has been like looping the string over and splicing it in a way that I want to try later today, or at some point. I'm a bit, I don't know, not too keen on the idea of like splicing this string, because it's so narrow, it's like less than a millimeter diameter, but maybe I will. But in any event, just basically make a loop and put it through here, which I like the looks of, and is a lot simpler than what I was trying to do with the belts. So let's get rid of all these features. We don't need any of this stuff. And yeah, this is what I was just trying to describe in the stream before. So the way that I was intending on this working with the belts is that I would feed the belt in through here, through this, and then fold it over on itself and then pass it back through, so that like the folded section would be stuck in here and can't pull through. And that kind of worked, but honestly it works a little bit too well insofar as I can't, once I get this in there, which is a little bit fiddly, but once I do, it is stuck and it is never coming out, which is a bit annoying if I want to ever change anything. So I like John's idea, makes it very easy to replace. So yeah, we can get rid of all these.
Difference doesn't mean anything bad. It just means that you're special.
Just means you're special.
You're one of a kind. One of a kind.
How did you survive? All right, so let me just check where this sits on the carriage. Yes, that's just flush against the carriage. So literally all we need to do is just cut a little groove. And John's groove is a very interesting shape. I guess that will print extremely nicely, but I don't really see any need to, like this can just be flat. I'm just gonna make it flat.
It just means that you're special.
So I want plain,
You're one of a kind.
how am I gonna do this? Got a better idea. I will first roll back before all the fillets. so we don't mix them in. Let's go 15. Nice big loop.
Different doesn't mean anything bad. It just means that you're special. You're one of a kind. One of a kind.
That's a very weird way to do that, but whatever. Cool. And now I can sketch on here. And the profile I want to cut out. I'll hide that for now. So I'm going to want a little groove that opens up. Is that right? No, I want to go the other way around. Yeah. All right, let's bring this back in. So this is only fitting a string that's like 0.8 mil, so it's not massive. But let's give it plenty of space. I swear half my clicks aren't registering. Yeah, if it looks like I'm picking these dimensions pretty randomly, it's because I am. All right, now we can sweep this. So good. Yes, this will print up like this. I might want to make that step a little bit more noticeable. Yeah, that's perfect. Although maybe slightly less big diameter. Cool. And last but not least, I can mirror. Cool. All right, so string goes in. It will terminate on here. There'll be a loop in the end of the string, however I end up doing that. Sorry to cough. string comes in, loops around, up over the pulley, down over the outside of this. It then runs straight into this rib. That's no good. That's no good at all. It's actually not really very lined up on the spool. I'm thinking I'll make it go out on the outside of the spool just so it doesn't hit this thing here. Of course, this would be a little bit better if I like dimensioned everything properly to have it go perfectly parallel, but whatever, that's fine. But this definitely does need to be cut out. So let's do that. So we probably want to err on the side of caution without completely destroying the actual like structural purpose of this rib. Let's see how that goes. Oh, oops, that's why. There we go. So now, yeah, nice. Yeah, that's much better. Although the string won't be able to go the whole way up the spool, so that's. Wow, I've really eaten into that. So I can probably add a bit of that corner back. Let's do it in the form of a chamfer. Of course, we have to fix this up. I don't really know why the color is changing so much there. Cool, okay. String goes on, over pulley. Does not hit the rib anymore. Gets wound onto the spool. Wind. Down, around. And back up. My mic and my camera just died at the exact same time, so I need to get a battery for the camera. I'll be back in just 1 second. Unless the camera actually died a little while ago and I just didn't notice, which is very possible. Maybe that's a sign. It's definitely a sign that we're coming to the end. We are very close. Just fix the camera. Why is that? There we go. All right, we're back. And we're pretty much done though. I'm really liking the look of this. Yeah, I just need to print everything And that should be that. I don't know if I'm a huge fan of how much it sticks over the top, but definitely good enough for prototype. All right, yeah, I'm actually going to call that there. I am ready for a sit down, I think. I am so amazed at how much live streaming takes it out of me. And I guess maybe if you like doing gaming sort of live streams, it's a bit easier because you just kind of, I mean, I don't know, maybe. Definitely takes it out of you though. Hang on. Perfect. We can end the streams today just how we started them, with Albie in hand. All right. Well, thank you very much, everyone. I hope you found this enjoyable. I certainly did. I'm very keen for this design. I am certain that between this design that we've just done and the two hand designs that I showed off in the earlier stream, I am certain that one of these will work. Definitely well enough for the purposes of getting definitely two balls in one hand done. 2 balls in one hand is pretty low effort, I would say. Definitely within the realm of possibility here. So fingers crossed, next week I reckon we'll have another juggle attempt. We'll see. All right. But for now, it is time to give this cat some love. So thank you very much for joining me today. I hope you found this interesting. And yeah, until next week, good luck with everything you're doing and enjoy your weekends. Goodbye.